Hello guys, welcome back to another video. I hope you all are doing well. Today we will be solving the 23rd problem of the Blind 75 series. The problem is House Robber 2. This is the problem guys. The problem statement is you are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. All houses at this place are arranged in a circle. That means the first house is the neighbor of the last one. Meanwhile, adjacent houses have a security system connected and it will automatically contact the police if two adjacent houses were broken into on the same night. Given an integer array nums representing the amount of money of each house, return the maximum amount of money you can rob tonight without alerting the police. So before moving towards the solution of this problem, I would like to say something. This problem House Robber 2 is extension or you can say the modification of the House Robber problem. So to solve this problem, we will be using the same techniques and concepts that we used to solve the House Robber problem. So it is highly advised to solve the House Robber problem first. Uh, then come to this problem if you have not solved the House Robber problem, because you will be able to better understand the solution of this problem if you have solved the House Robber problem. So it is must to solve the House Robber problem first, then come to this problem. Okay, now let's move towards this problem. So this problem states that you will be given an array and the elements of array represents the amount of money stored in the different houses, and you have to rob the money from these houses in such a way that you do not rob two adjacent houses simultaneously. And apart from the condition that I had in the previous question in the house robber problem, there is just one extra condition over here. This first and last elements will be considered as the simultaneous. So that means you cannot rob the first and last houses simultaneously. Let's understand this with the help of some examples. Okay, so uh, in the house robber problem, let's consider this example. Suppose the amount of money stored in the houses was 232. So we would have selected the first house and the last house to rob the maximum amount of money. The maximum amount of money that I can get by selecting the first and last house is 4. So you can check this is the maximum in this case. But here we are given the condition that the first and the last elements are adjacent. So in this problem, I cannot select the first and last element to get the maximum amount of money. So rather I will have to select the second element, that is 3, to get the maximum amount of money. So this is the slight modification over here. Let's consider the another example. Suppose the amount of money would be 1, 2, and 3 in the houses. So in the house robber problem, I would have selected the first house and the third house to get the maximum amount of money, that is 4. But as in this problem, the first and last elements are simultaneous, so I cannot select 1 and 3. So I will have to go for the other options. So what I will do to get the maximum amount of money, I will have to select these 3, because what were the other options? If I would select one, I could not select this 3. Okay, so I would be left with just one. I would get just one. The total amount of money that I would get is 1. So if I would select 2, I could not select 1 or 3, so the amount of money would be 2. So if I would select 3, the amount of money will be 3. That is the maximum I can get in this case. That is why the answer for this second case or the house robber 2 problem is 3. So there is just one extra condition over here in this question apart from the condition that I had in the previous question, that this first and last elements are also adjacent. You cannot rob these two houses simultaneously. Okay, so for solving this problem we will be using the same technique. So we will be using a little modification to solve this problem. Okay, so as the first and last elements are simultaneous, and one thing I know for sure that I cannot rob this first and last house simultaneously. This thing I know very clearly, that if I would have selected the first house, then I cannot select this house to rob, because these two are adjacents. Or you can also say that if I have selected the last house, then I cannot select the first house. So one thing I know for sure, that in my final answer, either I will select this house or either I will select this house. Either I will select the first house or I will select the last house. I cannot have this first and last house together in my final answer. Okay, so what I will do, I will break down this question into two cases. I will say either I will create two cases. In the first case, I will just skip the first element and consider all the other elements. I will skip the first element and consider all the elements of the given array. And in the second case, I will just skip the last element and consider all the elements. So why did I did so? The reason is very simple. As I told you, in my final answer, I cannot have this first and last elements together. Either I will have first element or I will have last element. So what I will do, I will create two cases. In the first case, I will skip the first element and consider all the other elements. And in the second case, I will skip the last element and take all the elements in the array, and I will use the same technique to find the answer independently for these two cases. And among these two cases, whatever case or whatever choice will give me the maximum answer, that will simply be my answer. Okay, let's write down the code for this particular approach. So this was the final space optimized solution that we wrote for the house robber problem. So we'll be using this only in this problem along with some modification to solve this problem. So let's see how. So as I told you, I will be dividing this problem into two cases. In the first case, I will take the first element and skip all the other elements. In the second case, I will just skip the last element and take all other elements. Okay, so let's create two vectors for creating these two cases. Okay, so in the first array, I will put all the elements apart from the first element, and in the second array, I will put all the elements apart from the last element. So for doing that, let's start a loop. But before that, let me store the size of this in some variable. So index for the first element will be 0. So if index is not equal to 0, I will push the element in the array 1. And index for the last element will be n minus 1. So if this condition gets satisfied, I will push the element into the second array. Okay, so I will pass these two arrays one by one in the given function, and out of these two arrays, whatever array will give me the maximum answer, that will be my final result. So let's call this as case 1. I will pass the array 1 in the function, and for the second case, I will pass array 2 in the function. And out of these two cases, uh, whatever maximum answer I will get, I will simply return that. So, but guys, there is one edge case over here. As in the first array, I am selecting the first element. I am just skipping the first element, sorry, and selecting all the other elements. In the second array, I am skipping the last element and selecting all the other elements. But if there will be exactly one element in the array, so then both the arrays will become empty. I will not be selecting any of the element in any of the arrays. So that is why I will have to handle that case separately. So if size of the array is 1, I will simply return the element that will be inside it. So I will return nums of 0. Okay, now this code looks fine. Let's try to run this. Okay, sample test case have passed. Let's try to submit this solution. And guys, yes, it got accepted. uh, Okay, now let's analyze the time complexity of this solution. So we are using two loops over here. The first one is this and the another one is this. So in both the loops, I am iterating from I equal to 0 to n minus 1, that is n times. So time complexity will be big O of n, and the extra space that we are using over here is this vector, these two vectors. So space complexity will also be big O of n. So uh, in this way, you can solve this problem. The link of the codes will be given in the description. You can check out the GitHub repository link that will be provided in the description. So that's all for today's video. We will meet in the next video. Bye bye.